So this problem says that we have a developer that wants to enclose a rectangular grassy lot that borders a city street for parking. If the developer has 208 feet of fencing and does not fence the side along the street, what is the largest area that can be enclosed? So I always like to draw a picture for these here. So this is going to be my city street, okay? And let's just say that this is going to be the rectangular lot that we want to enclose with fencing. Now, it says that we have 208 feet of fencing, and it says what is the largest area that can be enclosed. So it wants the largest area, and we are talking about the area of this rectangle here. Keep in mind that formula for area of a rectangle is length times width. So in order to figure this out, well, we need to know the length and the width of this rectangle here. And again, keep in mind we're only fencing the orange pieces here. These three sides, all right, not the green side over there. So we need to figure out how can we designate a length and a width for this, only knowing that we have 208 feet of fencing. Now, typically in math, if we don't know what something is, we call it X. But for the purposes of this, since we're using length and width, I'm going to use the width as my X. And our width is this side over here. Right, so the width is just going to be the width. We're not going to have any special names for it here. And what we know about a rectangle is that opposite sides are equal. So if I'm going to label the right side over here W, I'm also going to label the left side W. We just need to figure out what exactly is our length. And our length is going to come from this here. So we have 208 feet of fencing that we're going to use. Part of that fencing we're going to use for the width here. Part of that fencing we're going to use for the width here. Those are the same measurements. So technically we have 2 W's of fencing that we need. If we have 208 feet of fencing and we're going to use 2 W of it for those two sides, well, what we have left over, that 208 feet of fencing minus this W and minus this W is going to give us the leftover fencing that we can use for the length. Therefore, our length is 208 minus 2W. And that's actually enough for us to actually plug in to our formula here. So, area is equal to our length, which is 208 minus 2W, times our width, which we just said width. Multiply this out. Now, if we multiply this out, 208 times W just gives us 208W minus 2W squared. Now we're going to stop right there. It wants to know the largest area. And if it's wanting to know the largest area, what that tells us is we want the max area here. And if we want the max area, we're going to use the concept of maximization here. And in order to find the largest value that's going to work for this, to find the min or max of a quadratic function, that is what we have here. Notice we have 208W minus 2W squared. That is a quadratic function. And we want to find the max of this quadratic function. And we're going to find that max, specifically that W, our x value, by using negative b over 2a. This is a given formula to find the min or max of a quadratic function. Keep in mind that b is the coefficient of the first powered variable, so our w here. That means b is the 208, a is in front of the w squared, which is the minus 2. Plugging into this formula, the negative part of the formula, b is 208 over 2 times a, where a is negative 2. When we simplify this, we get negative 208 over a negative 4. And when we simplify that, we get a 52. That is our W. We designated that for our width. That means our width will need 52 feet of fencing, which means in order to find our length here, we just need to plug it into our little length formula that we created. So 208 minus 2W, when we know W is 52, that gives us 208 minus 104. which is 104. So that means our width was the 52 feet. Our length is 104 feet. If they want to know the max area of this thing, well, we know that area is length times width. So that means we're going to do that 52 times that 104, which gives us 5,408 square feet here for our area.